go. So welcome everyone. This is, I can say now really loud and clear, the last EU Code Week webinar for 2023. And we are really happy and proud to present an EU initiative, an EU product that we're going to explore all together. You can always, if you have questions for future webinars, if you have ideas for future webinars, contact us. We are really happy and open, and we're gonna organize for you a big workshop day to learn more on any hyped and new technologies for education in March. So we are always open to bring you the best closer to our EU Code Week community. But today the best is Open Roberta Lab, and it's an open resource project produced by Fraunhofer in Germany, and it's a groundbreaking programming environment that empowers you and not that teachers, but also robots as we learn just, and microcontroller boards to be used. And we will learn more about how to use it, the bit of a background about it. It's a really interesting tool, and I'm sure that all of you would be really keen to explore it further. So for this, we have today with us Thorsten. So we are happy to get into the world of Open Roberta and have a specialist with us, a person who knows how to help us explore it further. Welcome, Thorsten. We're really happy to have you here, and I won't spend any more of your time. I will leave you share every single detail about Open Roberta with our community. We are already 36. Thank you so much for taking time out of your day to join us in our EU Code Week webinar. We know that this is something that is not easy, that you all have busy schedules, families, school, wherever, and you are here with us. So for one more time, I would like to thank you all, and let's explore together this last piece of webinar that we have prepared for you, our EU Code Week community.
Thank you very much, and welcome everybody to my tiny little webinar about the Open Roberta Lab. My name is Thorsten Leimbach, so I'm from Germany, as Irene said. I'm working for the Fraunhofer Society, especially for the Fraunhofer Institute for Intelligent Analysis and Information Systems. I'm heading a business unit called Smart Coding and Learning. I started working at Fraunhofer around about 20 years ago. I started working in a project called Roberta, Learning with Robots. It's a project where we wanted to get more girls and young women into STEM. So we started it in the year 2002. And in the year 2002, my institute formerly was a robotics institute. So we've done a lot of research in robotics, and we figured out, okay, robots are quite cute and smart tool for getting girls and boys interested in STEM. So, and then we figured out, okay, let's do a project financed by the German government, where we can figure out how we have to address especially girls with robots and coding. And we ran that project for over 4, 5, 6 years. It was also after the German funded project, we also became or got a Europe funded project called Roberta Goes EU. And during all these years, we used mostly Lego robots and the Lego environment. And then we trained teachers all over Europe, especially in Germany. We trained over 5,000 school teachers here, and we designed special robot courses here in Germany, where I think over 500-600 pupils participated over the last 20 years. But during the years, we said, okay, if we use probability software, like the Lego software. The teachers have to install the software on their computers. They have to maintain and update the software, and they only could code one special robot system with it. And so Scratch came up in the years 2008, 10, around about that. And we said, okay, it would be very cool if we could develop a coding environment, a programming language inspired by Scratch, but working in the cloud and for real robots. So that was around the time 2012, 2030, where we started also a cooperation with Google. And Google then founded a project called Open Roberta. And during this project, we developed the Open Roberta Lab and made it possible that you can code real robots and microcontrollers only by using a browser. I think we've been one of the first ones who have done this for the Lego robots, and then for other microcontrollers like the Arduino or the Microbit or the Calliope here in Germany. It's a well-known system. And that's what I wanted to do today, is that I give you an introduction into the Open Roberta Lab. So how is it structured? How can you use it? How you use it without robots. So we have a simulation integrated. And if you're interested, I said beforehand, I will give you an insight into our latest release. It's not published yet. There we have integrated artificial and neural networks. So if you say, okay, you're interested in how to code a robot by using neural networks and how to train a network and then to see if it works on a robot or not, just raise your hand and I will try also to give you a short insight what we are doing right now and when we will publish it and how you can use it for yourself in your classes or with your students. Okay. So 3, 4 hands saying, okay, they're interested in neural networks. Okay.
Oh, I see 6 already. That's nice.
7, yes. Okay, so at the last minutes, I will also figure out that. One question beforehand, who of you is familiar with the Open Roberta Lab? Okay, so around about 6 people are familiar with the Open Roberta Lab, okay? So then I will give you an introduction to it. So hopefully you can now see my screen right now. So, okay, here we go. So that's the Open Roberta Lab. As I said, it's a bit inspired by Scratch. We are using Blockly, of course, but we started in the year 2014. I guess during this time, Scratch wasn't able to provide coding in the cloud. This is a cloud-based environment, so it's running on our servers here in Germany at the Fraunhofer cloud. We do not using any cookies, for example. You do not need an account. It's completely open source. You can have the complete code repository on GitHub. It's an open source community project. So if you're interested in joining us, feel free to do it. We are financed by the German government, by companies, by foundations. We are doing a lot of research projects as the one with the neural networks, for example. So that's how we are structured here in Germany. The Open Roberta Lab will be used monthly by around about 300,000 users from all over the world. So the users came from nearly 100 countries worldwide. We have integrated round about 22 different systems. Here you can see the systems, for example, the M-board or SenseBot. It's a microcontroller system here in Germany. The Now robot, it's a humanized robot. The microbit, Joy-Car, microbit itself, the Calliope, the Lego robot. So there are a huge range of different systems integrated in there. And here you have also the neural networks, which I will show you later. So the one I wanted to use is the Open Roberta Sim. It's for coding simulation robot. It's, I think, the easiest one to start with because you just write your program and then test it in the simulation. So I will use this one, the URL you can see here, the lab.open-roberta.org. We also have a offline version. So we also provide an image so that you can run the whole Open Roberta Lab server environment and architecture on a Raspberry Pi, for example. If you're interested in this one, I can give you all the links and information afterwards. Okay, so let's start. I hope you can see it quite well. I will change to English. These are all the different languages we have integrated. We are working here together with volunteers who are helping us translate the Open Roberta Lab into different languages. If a language is missing, just contact us, and we would be happy if you join us and translate a missing language into your language, for example. Okay, I switch to English, and here you see the programming environment and also the programming stage. So every program you code starts at the start block. So this, for us, we thought it's very helpful for the kids and youngsters to have a block where you can put all the other blocks and connect them, because this helps you to structure your code and to think, okay, here starts my program, and all other coding blocks I will use from then now have to be connected to the starting block. So it's quite simple. On the left-hand side, you have a lot of categories. In these categories, you have different kind of code blocks. It's a visual programming language, or graphical, or iconic, if you want to say so. And if you want to start coding, the easiest way is you go to the action category, then you put a drive block, you connect it to the starting block, and then you see, okay, that's a block. I have a robot, and my robot should drive forward with 30% of the maximum speed and with a distance of 20 centimeters. So just connect it this way, and then now test it. You have to go to the right-hand side, and here you see a lot of different tabs, and one of the buttons here, it's called Sim for simulation. If you click on that, then you see your small, tiny robot. It's a quite simple robot. It has two wheels or two motors, one on the left side of the robot and one on the right-hand side of the robot. This robot is also equipped with some sensors. Here, the ways you can see here is an ultrasonic distance sensor. Then you also have the possibility to use a bumper. So if an object hits the robot, or the robot hits an object, then the bumper is activated. And you also have a color sensor. That's the one in the middle here. It's a sensor which looks down to the ground and detects light or different kinds of colors. So if you want to start your robot, that's the front and that's the back. You have to push the start button. And if I click it, then you see, okay, my robot moves forward for 20 centimeters. You can change the number and then you move your robot forward. That's quite simple. Can bring it to the back. In this environment, you have a huge range of possibilities. So the first one is, okay, I switch the environment if I go here to the change the theme button, and then I have a clean environment. If I push the enable draw trail button, then my robot will draw a line, a black line, where you can see the path or the trail of the robot. Okay. So, and when we're working with kids, then we start with small little programs. So let your robot drive forward, then let your robot turn right or left with different degrees, for example, 90 degrees. Then test your robot. Change the scene here. And then you can start again. And your robot turns. Okay. And here you can see, okay, that the turning is not a curve. It's a turning on point. So both motors are, the one is turned forward, the other one is turned backward. And so it moves, makes a right turn. Then you can go on quite fast. Now can say, okay, let your robot drive a square, for example. I can show you how it works. It's quite simple. You can use a different block. You can copy this one and again. So, and always your program starts here and it ends if no block is coming. Then your program is stopped. And now one, I think, really interesting feature is if you're working with kids in schools, then it's quite hard to imagine, okay, which block is now activated if you're a senior robot. So I will test it. So I start the program, but you have no idea, or you can guess, okay, this is, we are here, then now we are here, then maybe we here. So, but if the program is a bit more complex, then it's quite hard to figure it out. So that's why we use other view, and it's called a debugging mode. And if you switch to the debugging mode, you have the same stage, the same scene here, but now you can see which block is activated. So this helps the kids debugging the program, helps it to structure it, to figure out what is your robot and why is your robot doing this and that. Okay, and that's quite simple. And now normally you move on and say, okay, we have now coded a square. Can we do it better or easier, make it more easier so that we wanted to use less blocks? And then, okay, what you can do is you can use other things. For example, you have here in the control category, the control blocks. And here you have repeating loops. It's a loop which repeats all the time. And here we have a repeating loops where we can say, how many times the loop should be running. And quite simple. So every block here was used 4 times. So we put one drive block in the loop and one turn block. So every block you want to be repeated, you have to put it in the loop brackets here. And then again, we switch to the debugging mode and see, okay, it's working quite easy. And here you can see the difference. I forgot here to change the distance from 20 to 60, and that's why I'm not drove square before. So now it turned the right way. And also, if you can see here, if your robot does not a real 90-degree turning, that is because you have to lower the speed here in this place, because we have here a simulation environment which is a bit close to a real robot, because if you are doing it with a real robot, it depends on the friction of the robot, if he is able to do a 90-degree curve or not. So it depends on the floor or on the ground the robot is driving on. And here it's a bit the same. So if you want your robot to be more precise, you have to lower the speed. Yeah. Okay, so let's see if it works. And our interest is that we really want to do it to make it quite simple and easy to start coding by using a robot. Why using a robot? I said real robots are a really fascinating artifact for kids and for youngsters and teenagers, and also for adults and elderlies. But if you're doing coding by using a robot, you have a lot of mathematics and physics coming with it. So meaning, if you're saying my robot drives a distance 60 centimeters or 90 degrees, you have normally to know a lot of things. So normally you have to know the wheel diameter or radius. You have to know the distance between the wheels, for example. You also normally have to know how the shape of your robot is, where your sensors are located, how the sensors are working, which data the sensors deliver, what can you do with the data, in which speed or time is the data coming into your robot. So there are a lot of really interesting and fascinating math and physics coming with when you're using a robot. For example, I showed to you, here's the robot configuration, and here you can see you can edit or change the wheel diameter, because normally if you're using different kind of robots and different kind of wheels, then you have to adapt this. And also the drag wipe. So how many distance, or what is the distance between the two wheels, left wheel and right wheel. And if you change that, for example, you can do that, then you will see in the simulation the both wheels are now much closer together. If you say, okay, they are 25 centimeters away from each other, then you have this. And then, of course, your robot drives also forward and turning 90 degrees, because it's the whole math stuff is done within the blocks. So, but if you want to figure it out or doing a bit more math, then you can easily use a robot by explain the kids why radius and pi is something worth discussing within the classroom. So why math is really important to teach, because if you want to code a robot and steer a robot, you have to know about mathematics. Okay, so moving on. Our robot, as I said, is equipped with sensors, so we can do some funny stuff with it. We can say, okay, so I put this away. I want that my robot drives forward, but only if a object comes close. So how can we do that, for example? Here we have a block called wait until. And if we put it in the first, then my robot waits until a specific action is true. For example, if I say I have a distance, if something is closer than 13 centimeters, then my robot will start. So let's see if we can do it. I will change it here this way. Looks a bit better then. Okay. So then that's my object. And I see that. Okay, I do it again. I show you that you can, here I click on the open close sensor data view, and here you can see all the data provided by the robot, and here you have the ultrasonic distance range sensor. And if you come here closer, you see the distance goes down. And if I now start the program, then you can see if something comes closer than 30 centimeters, then the robot starts driving. Okay, that works very fine. You can also do, of course, other things. I will switch the scene here. You can, for example, do things like that. My robot should drive forward until something happened. For example, until my color sensor detects red, for example. So then you can say, I want to try to draw a color field, and then I change the color here to red, for example. And if this action becomes true, then my robot should start play a tone, for example, or doing things like that. So. And here now, I use the drive forward speed block. Okay. Maybe could hear it, so it makes a tone and starts flashing. I could also do things like that. My robot should drive, for example, backward 60 centimeters. And see. So it drives forward and hits the yellow field and then drives backward. See again. Huh? Okay, it's not working. Backward. Where's it? Okay, now it's working. Okay, that's a small bug in this environment. So, but I think here you see we are now here, and then we are here. Okay, so that's working, and of course you can now start figuring out a lot of other things. What you can do with using a robot. What's important for me is you can also switch and have a look at the source code. Here we are using a Java source code. And here you can see that's all the Java stuff you need. And here you can see the things you need really for the robot. We can switch, for example, to EV3Dev. That's a Python environment. So here you have the Python code. That's quite the same. And if I here now, for example, wait a minute. Okay, if I go back and put something in a loop and then I reload the source code, then you can see, okay, now we have here a while true statement and everything here will be repeated all the time. Okay, so then add other blocks here, say maybe things like that, and do something like that. And then you can see, okay, we add all the things here. This is this block here. Then you have here the statement, the if statement, and all the things. So you can have a look at the source code. You can download the source code and then reuse it in other environments, for example. That's quite interesting. And of course, if you use other robot systems, for example, the Calliope Mini, you have the same code structure. So that's very important for us. Of course, you do not have the same coding blocks because it's not a driving robot, but the idea of how the blocks are structured and, for example, the control blocks are quite complete the same blocks. And that's very important because if you change the systems, you do not learn the coding blocks. You can nearly use the same structure and have the same logic and math blocks and all the things. So if you are using different kind of systems, it's quite easy to reuse the blocks you're already familiar with. Okay, so going back to the robot, but now I give you a short insight into our neural network system, and therefore I have to switch to other coding environment. So I now show you the, let's see, wait a minute, wait a second. Yeah, there's a question.
Yes, we see Hunter. Is anyone having a question? Paolo, all good?
I think Paolo.
Yeah.
Okay.
Maybe it remained from.
Sorry, I forgot to to disable this. Sorry.
No worries, no worries.
Okay.
So now I am on our developer server, and here you can see I choose the system Open Roberta XNN. XNN is for explainable neural networks, and here you have two new tabs here above, and these two tabs are for the neural network. And also we have here a new category also called neural network. And so let's have a look in how we can code our own first neural network by using the Open Roberta Lab. I go to the neural network define tab, and here you can see a really, really small neural network. It depends on only 2 neurons. Here it's called N1, and this is called N2. It's an input neuron, and this is an output neuron. Here the data comes in. So if you, here you can say the data comes into the network with this neuron. Then you have here a edge, and on this edge is a weight. So, and these two neurons are connected by this edge, yeah. And that's the output neuron. Here, the data which are comes here, you can reuse, for example, steering your robot. Okay. One short thing, we integrated this kind of neural network for the Ministry of Education here in North Rhine-Westphalia. It's the idea was to integrate neural network, especially for pupils in the class 5 and 6. That's around about 12 years, 13 years old. Some of them have already coding experience, some not. So, and the idea is that you mostly, or a lot of people, if they are talking about neural networks, they're talking about it's a black box. And that's not really right. So it's right for if you're thinking about large language models or deep neural networks or huge networks, because then you have no clue what's going on really inside and why the neurons are connected like they connected. So, but if you have a really simple, small network, a small feed-forward network, so the data is coming in here, and the data is moving from the left side to the right side. That's quite simple to understand and to explain, we think. So what happens in this really simple neural network? So the data which comes here in will be multiplied by the weight of the edge. So the result of this neuron is this value multiplied 1. So, okay, I give an example. Here I can put in some data, for example, 2 and 3. Okay, then I say the weight of the edge will be 2, for example, and then I can run the network layer by layer. So I start with a 2, and then I have a 2 multiplied 2 is 4. Okay, let's see if it's right. Okay, it's 4. Then we have a 3. 3 multiplied 2 is 6. Okay, that's it. That's quite simple. You, of course, can also use negative weights, doing the same. 2 multiplied minus 2, it's minus 4, minus 6. Okay, quite simple. You can do other things like, okay, using a second neuron, for example. I can say here a half. Then you also have to put in new data for your second neuron. 3, 2, and then see. Okay, 2 multiplied minus 2 minus 4, 3 multiplied a half, it's 1.5, and then I have minus 4 plus 1.5, it's minus 2.5. Okay. So, and that's it. So you have a neural network, and it's a feed-forward network, and everything you need is addition, subtraction, and multiplication. And that's it. That's quite simple. So, okay. And the interesting thing on neural networks is how can we train a neural network? Yeah. Okay. So we now go back. I will start quite simple. What's happening here? Okay. I cite this. And for the training of the neural network, we have an additional tab here. And here we are using backpropagation, meaning we minimize the failure here from the calculated value to the expected value. So, okay, how does it work? I again have to fill in data. So there I think about a function 2x plus 1. Okay, meaning if I have for the x a 2, then I have 2 multiplied 2 plus 1 is, okay, wait a second, I will make it a bit easier. So 2x plus 1, meaning if I have a 2 for the x, then I have 2 multiplied 2 plus 1 is 5. If I have a 3 for the x, or I replace the x by the 3, then I have a 2 multiplied 3 is 6 plus 1 is 7. And for 4 multiplied 2 is 8 plus 1 is 9. Okay, so that's our function. So really, and that's really important. So that's the data I put in the network, and that's the expected output value here. So that means if I, after finishing training my network, what I want to learn is that if here's a 2, then my network should calculate a 5. And for the 3, a 7, and for the 4, a 9. Okay. And therefore, I have to say the learning rate. So that's the distance between every learning, how fast the network should learn. Normally, I use something like that. And how many trainings? So how many, one epoch is one complete run through the data. So this 300 means that I run 300 times the complete data set here. And now see what happens. So here you can see the loss. The training loss means that this is the difference between the expected value. So for the 2, I expect a 5. And the training loss is the difference here. So see, if my network gets a 4, it calculates a 7.17, but I expected a 9. And that's quite this training loss here. Yeah. And meaning, okay, I have to retrain my network because that's not correct. So I normally redefine all the weights. And then I say, maybe I want to use 800 epochs here. And let's see if it works better. So in here you can see, okay, I got the 4 and I expected the 9. It's better. It's better than before, okay? Meaning maybe I have to use more epochs here, for example, or maybe also I need more datas. Normally, we also can see if we lower the learning rate, can see what happens then. Okay, that works much better. So lowering the rate means that the steps between the adaptation of the network are faster. So, and here you can see, okay, it's quite close to the 9. And then it's up to you. It's okay for you or not? So if not okay, then you have use more epochs for example. So now you can do a lot of interesting things also together with your robots. You can now think about which data is your robot using, or which sensors have your robot. As I said before, our robot here has a color sensor, for example. So this robot can detect color as blue and yellow and green and red. And I coded a smart program and this program is using 3 neurons. And therefore, what I do here is that I say my sensor, my color sensor, should detect RGB, so RGB color sensors. So it's red, green, and blue. And every color can be explained as an RGB color. And therefore, you can split off the color into 3 values. And these 3 different values you put in the network. And then you can train the network that your robot, for example, should stop if it detects a red color, for example. And I will show you how easy it is. So what you need is a set of data. And I prepared a set of data here. And these are the RGB values. For example, here, these 255 means that it's red. So if you have a red color, then you have 255. And then green is 0, blue 0. And then you have to say what should happen with your motor output. So in here I say, if you detect a red color, put your motors to 0. Okay? And I erase the others. And then the other important thing is, if you have detected a white color, then you say to your network, I want that my robot should drive forward. And drive forward is that these both output values will be forwarded to the motors. And therefore, the motor speed should be up to 50%. Okay, let's see the program here. I put in the color values to the neural network. And then I use the output of the neural net for the input of the motors. Yeah, so you can also put here a number, for example, these 50%, then it's the speed of your robot. But I say I want that the network will provide the speed of each single motor. And now see what happens if we are training the network. So, okay, that's not working. You can see it here. The numbers are in a different direction, meaning that the learning rate is too high. I have to add a 0. Now here you can see the training loss goes down. You can stop the training and test it. Okay. It's not working, so maybe I've done something wrong. No. Then I have to train it again. Let's see why it's not working.
So in the meantime, sorry, just to flag that we have a couple of questions in the chat, so we can ask them in a while.
I just showed, I hope now it's working. Let's see if it's working or not. Okay. Oh. Okay, now it works. So the robot drives forward, and if it comes to red, it stops. And that's how you can use neural networks together with the robot, for example. Okay. Yeah. What are the questions?
So we have the first question, which is from Dino. How is going with multitasking? I don't know if it's a question or a statement or...
Multitasking, you're meaning parallel threads. If you want to code parallel threads in the coding environment. So far we are not using the possibility of coding parallel threads because we think it's mostly too advanced for the kids and even for the beginners, especially if you are using or want to code hardware systems. Because if you code parallel threads and using the same motors, for example, the whole system can crash, and it's quite hard to understand the principles behind parallel threads. So we think it's not helpful if you want to start learning coding.
Great. So the second question is, can you give us a real-world example for the two neurons model? For example, a robot with a single motor that can only move back and forth and one light sensor, and what exactly the learning rate does.
So, okay, go back to the Open Roberta Lab. So I think what you've meant is if you have only one input neuron, then you can define two output neurons, and then you can split the incoming data into two output values. And therefore, you can say, okay, that's my left motor, or left, and that's my right motor. And then you can change here the weights and therefore you can split these data into two different motors, and so your robot will also be able to drive curves and drive forward and backward, whatever. And you also be able to add, of course, hidden layers. You can make really complex networks as well. So, other questions? So,
are there any tutorials or lessons plans for nets?
Yeah, nets. I'm not sure what nets means, but we have a lot of tutorials and learning materials. Mostly in German so far. We provide tutorials here. We provide coding examples in the gallery. So I'm now on the developing server. If I change it to the official lab, then here you will find a lot of coding examples. And we also provide for other systems online tutorials. So here you can, it's in German so far. So if you're interested to do in other languages, help us translate it. And here you have really step-by-step introduction and only one block, for example. So, and then you can move on, and you have more blocks here provided. Okay. And you also have here at the Roberta website, we also provide a lot of training materials, but of course, the most are in German so far. So here you have the introduction to the Open Roberta XNN neural networks. We have other coding unplugged sessions, all kinds of things. Yeah.
Nice. So follow-up question, is possible for red block to disappear after interaction with robot?
The red block, you mean if in the coding environment, here you have this block doesn't disappear, and if you integrate some color fields, they are not disappearing, but what you can do is you can change the color to white, for example, then it disappeared. We are now figuring out new features for the whole simulation. For example, that each each block becomes a weight, so you can move it. One block, or if you have two blocks, you can't move it, for example. But it's coming next year. It's a bit far away.
Nice, a lot of things to looking forward to. So I'm moving to a final question, and then we have also a request for sharing these links to the chat, but also I can follow up with an email with you with useful links from Open Roberta, so this is not a problem. And about the final question, can you use various methods of like reinforcement learning or supervised learning?
We are now thinking about reinforcement learning, actually. We have plans to do it, but it's not that simple. So it's not that easy. But hopefully we will provide it till the July next year. Yes. And Breitenberg vehicle, exactly. So Breitenberg vehicle, you mean doing things like connecting the sensor directly to the motors, for example. Yes, that's I can provide some slides for that as well. Yeah, because that's working quite nice. All the Breitenberg stuff. Yeah. I will share the links. Should I provide the links in this chat, or is it possible that we send them an email?
So maybe it would be better to share them with me via email, and I can then disseminate all these useful links to the people that joined the meeting and have registered to this meeting. So if you haven't registered, so I know that you're interested for the link, please register here. I'm gonna share with you now the link for the registration. And you can register, and then I'm going to find that you're interested in, and I'm going to share with you all the links that Thorsten will share with me. So is there any other question? I've seen like a lot of interest around Open Roberta. It was a really powerful webinar in terms of we dive into the tool, and it was interesting to get to know the functionalities step by step. And for me, this is always helpful because it gets us more familiar with the tool and get us to understand all the concept behind and how, to click, and it's way easier to do it in an interactive way rather than watching an online video from your website, etc. So thanks a lot for joining. Thank you for sharing all this insight with us. It was actually great. I don't know if you would like to have any closing statement for our community.
Thank you. It was fun showing a small, tiny part of the Open Roberta Lab, but you can do a lot of more things. You can simulate 10 robots parallel, for example, and you can create accounts for your kids, for the class, all these things. So the links we provide you the link within an email. I think that should be the best way. If not, I can also forward it to here in this chat. But I think I will send you an email with all the links and all the things. That's the best way.
That's great. Thank you so much. Thank you for to taking the time to do this for the EuCodeWeek community, and thanks all of you that joined to this webinar, to the final webinar of 2023. We will upload this webinar also on our YouTube channel in case you would like to check Open Roberta step by step and stop and start at your own path. Feel free to visit our YouTube channel and find out more and check all the stages. Of course, as always, I'm gonna follow up with an email about the recording and all the useful links. And I would like to thank you all for this amazing year with EuCodeWeek webinars, that you were here raising questions, being interested in our topics, and really motivated to learn more every day. So thank you so much for that. And also for more things are gonna come. You see how many updates Open Roberta will have in the future, and I'm sure that they will be really happy to share them firstly with us and get to know us better, what is happening in their tools. And also see you down the roads. More excited things are coming for EU Code Week, and we are really happy and proud to have you as part of our community. And for now, I'm gonna wish you all a happy holidays, Merry Christmas, enjoy your time off and your break with your loved ones, and take care, stay healthy, eat and walk around to the amazing Christmas sceneries of our towns these days. Thank you all that joining us, and have a lovely evening.
Thank
Bye,
you.
everyone.
Bye-bye.
Thanks a lot.
Bye.
Bye.
Thank you. Bye.
Bye.